Hello, this video is a continuation of previous training showing how to use IndraControl to create BACnet IP server and client. It was presenting most common configuration where client was continuously polling data from passive server. Additionally, BACnet standard provides services that allow a server to be transformed from passive to active. This active server sends notifications of change of value to the subscribers. The BACnet COV system is not a mandatory part of the protocol, and each vendor decides if they want to support it. We will use BACnet network from previous exercise and first modify a logic for our XM21 server. We'll go back to our IndraControl engineering software and open our BACnet server project. In this project, we have already a logic to initialize BACnet protocol and a small program to change our monitored value every PLC scan, and that is every 10 milliseconds. This is too often for COV notifications, so we'll copy this project into a new one called BACnet Server 4 seconds, and here replace this program with a new one where modifications are done every 4 seconds. And analog value variable is increased by value 1.1. After adding this new program to task list and downloading, we can see our program and entire BACnet server running properly. We can also use our BACnet Explorer and see our server running on a network. Our next step will be conversion of our existing XM22 standard polling server into one that can subscribe for COV notification and which can also process the notification messages. So we go back to our existing BACnet client program and we can see control polling data from our new modified server. First, we'll copy this program into a new one, XM22 BACnet Client COV. Here we keep parts of the program responsible for BACnet IP data link and BACnet start, and delete all parts of the program used to pull data from server standard way. Now we add logic for COV functions, and we use example available in a help file. Since first step is already done, we go to step 2 and create a enumeration definition file, test state. You can see how easy it is, since we can copy code directly from help file into our logic. In step 3, we'll create special function block for COV notification. Please note that this function block uses internal interface BACnet event consumer. We can check this interface in our standard BACnet library, and we can see that this interface will be called when server events occurs. And at that time, it will also call this special BACnet events callback method. So to create this function block, first we add a new POU named fb-cb-conf COV notification. Then we can implement our interface by simply selecting it from the list. Now we can see our new function block with declared interface and automatically added required method. We go back to the help file to first cut and paste a declaration of variables for our function block. Then we copy a code for main function block. In step 4 of help example, we have a code for our callback method, and first is a declaration list. We do not need to copy that because declaration list was added automatically when we created function block. To finish our function block, we must additionally cut and paste main code from help's example. Following step 5, we will create new program COV. This program will use our function block to register our server to subscribe to COV notifications, and then monitor and process received notifications. So we'll go back to our logic and add new POU, then select it to be a program and name it COV. Back in our help example, we copy declaration and paste it into declaration field of our COV program. And last, we cut and paste main code for this program. When we look into this program, here is a part when registration with server is activated. And here, in initial step, we need to set our server parameters. So first we must set a device number for our target server. And it is number 21. We can also change comment here to better describe our server. Next element is object type, and in our case is type number 2, AV, and it stands for analog value. The last one, object instance, we leave as number 1. Now we need to add our program to PLC task. And then compile and download. Now we can start our program and see our COV value changing by 1.1 every 4 seconds. We can also check our network using BACnet Explorer and see the same analog value in our BACnet server. We can also use BACnet Explorer to see active COV subscriptions. And you can see here that our server has one active subscription with our client. That concluded our video. Thank you very much for your attention.